Welcome to Maths with EJD. Still talking about generating functions. We are focusing today on in this video on the probability generating function of the Poisson distribution. Okay. Um, so basically, for I think in my probability playlist, I dealt a lot with Poisson distribution. So you want to check that up under probability. So for a Poisson random variable, Poisson random variable x with parameter lambda. So it has a parameter lambda. The probability mass function, the probability, the probability mass function helps us to get the probability generating function. So the probability mass function, PMF, is probability that x is equal to k is equal to lambda raised to power k e raised to power minus lambda divided by k factorial, where k takes value starting from 0, then to 1 to 2, and so on and so forth, with probability generating function, with probability generating function as PGF, probability generating function, PGF, which is GXS equals e raised to power lambda into s minus 1, e raised to power lambda into s minus 1. So this is the PGF for a Poisson distribution. Okay. Now you may be wondering, how do we actually arrive at that, right? So if we follow the basic definition of PGF, right? That's actually something like this. You have GXS to be summation from is it x now? X equals 0 to infinity. Probability x, then s raised to power x. So from the very definition of Poisson, so you have P of x equals k, and that is equal to uh lambda k e raised to power minus lambda all over k factorial, right? So we can now begin to do, we can now have a kind of, we can have all the terms, right? So when x is p probability that x equals 0 is simply uh that means k is 0, right? So we have lambda raised by 0, e raised by minus lambda, then 0 factorial, that is e minus lambda, basically. Okay, then we have probability that x is equal to 1. That means k is 1. So we have lambda raised by 1, e raised by minus lambda, 1 factorial. That is simply lambda e raised by minus lambda, like that. And then if you go for 2, that's probability that x is equal to 2, meaning that k is 2. We have lambda squared e raised by minus lambda all over 2 factorial. So that is, that's lambda squared e raised by minus lambda all over 2 factorial, right? Then we can go on like that. So let me stop at 3. Probability that x is equal to 3. That means you have lambda raised by 3 e raised by minus lambda all over 3 factorial. That's simply, okay, I mean, even starting from here, right? There's nothing to really simplify, so we can just leave it the way it is. So if you now try to get, to follow the definition, so we have G X S equals summation from x, right, equals 0 to infinity of P X S X. Okay, so in that case, we have P0 S0, P1 S1, P2 S2, P3 S3, and that goes on like that to infinity. So P naught S naught, P naught S0 is basically, so this is like P naught, this is our P1, okay, this is our P2, and this is P3. and so on and so forth. So P naught is just e raised power minus lambda. So we have e raised power minus lambda. S naught, that's just 1. So next, we have P1. P1 is lambda e raised power minus lambda. So this is lambda e raised power minus lambda. Then P2 is lambda squared e raised power minus lambda all over 2 factorial plus next lambda 3 e raised power minus lambda all over 3 factorial plus all the rest. So, I mean, we can see a pattern already. So this is e raised power minus lambda into 1 plus lambda squared plus, plus lambda squared over 2 factorial plus lambda cube over 3 factorial and all that. So you can see this expression you have in here. Okay, yeah, I forgot to put all the s's. So this is actually with s. This is s squared. This is s cube. So this is 1 lambda s. This is lambda s squared. This is lambda s cube. So from that pattern, right, it means we basically have this whole expression. If you remember the exponential function, so this actually looks like the exponential function, which is e raised to power, that's basically e raised to power lambda s. Yes, that's e raised to power lambda s. So basically, we have this whole thing. So don't forget, it's still gxx. So let me even switch over now. So we have gx, let me just change it to something totally different. So we have gxs now to be e raised power minus lambda, this one, multiplied by this expression is looking like the exponential function. So it's basically e raised power lambda s. Okay. So from here now, we can factorize, we can put everything together. So we have e raised power lambda s minus lambda, if you like, and that is equal to e raised power lambda into s minus 1. And that is why we have this expression for that, right? E raised power lambda s minus 1. So the PGF for Poisson distribution, the PGF for Poisson distribution is GXS equals e raised power lambda into s minus 1. So we can see how that is derived. So let's get an example to drive it home. So example, let x be a Poisson random variable. For Poisson, all we need is the parameter with parameter lambda. So find the PGF of x. So that's easy to do, right? Because we just already know, we know the generating function. So we just substitute, that's all. So the solution is such that the probability generating function for a Poisson distribution, is given by gxs equals e raised power lambda s minus 1. And so if lambda, the parameter, is equal to 4, we have gx s to be e raised to power 4 s minus 1. If you like, you can say that's e raised to power 4 s minus 4. So you can have it that way. I mean, so that's basically what that looks like. And that's that. So that's how to find the That's the PGF for a Poisson distribution. The most important part is, once you know the general formula, just substitute the probabilities and see how the pattern goes, and then you can get the general form. So every other thing will just now be how to substitute. So if you now need the moment and things like that, you differentiate and substitute one and things like that, depending on whatever you require. So this is how far this goes. All right. So this is how this goes. Now, so you don't want to miss the next one also, which is the PGF of the geometric distribution. All right, so you don't want to miss that. So if you have not subscribed to the channel, if you have subscribed, thank you very much. If you have not subscribed, please go ahead and do that right now. Hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know how helpful these videos are for you. And let me also know if there's a topic you'd like me to teach or a problem you'd like me to solve. Then like and share so that more people can have access to this great content. Till I come your way again. Keep doing maths right. Bye.